Hello guys, welcome to my YouTube channel. This YouTube channel is created just to help you understand only calculus from calculus 1 to calculus 4. Today we'll be discussing, as you can see from your screen, function, domain, range and codomain. Now a function is a rule that associates or assigns each element in the independent set, say X, to a unique element in the dependent set, say Y. Now, an example of a function, so that you can understand in a better way, an example of a function is y is equal to x plus 3. This is a linear function. It is a type of linear function. A linear function is a function in which the degree of the independent variable is 1. Now, when I talk of independent variable, I mean a variable in the independent set. For example, our independent variable in this function is x. X is our independent variable, while the dependent variable is y. Why are we saying y is a dependent variable? Because for you to know the value of y, you must know the value of x. You must know the value of x for you to know the value of y. Of course, you can start from y to x, but in real sense, for example, in case you are getting a value for this case, this is a function of y. I mean, this is y, which is a function of x. So it means you have to know the value of x for you to know the value of y. So x is independent. It doesn't depend on y, but y depends on x, because you have to know the value of x for you to know what is y. For example, if you put x to be 2, then it means your y will be 2 plus 3, which is 5. So it means x value is 2, which is not depending on y. But y value is 5, which depend on the value of x for it to be known. That is a function. Now, there are various types of a function. We have linear function, which I've already explained. We have quadratic function. Quadratic function is a function in which the power there is now 2. For example, y is equal to x squared plus 3x plus 2. This is a type of quadratic function. We also have cubic function. Cubic function, for example, y is equal to x cubed plus x squared plus 2. That is an example of cubic function. We also have logarithmic function. Logarithmic function, for example, y is equal to log of x. This is an example of logarithmic function of base 10. We have other function like trigonometric function. Trigonometric function, for example, you can say y is equal to tan of x, for example. Because of this tan, this becomes a trigonometric function. That is a function. Any rule that is going to associate or assign a certain value in the independent set, say x, that's going to give a specific value in the dependent set. That is now a function. Now for domain refers to all elements in the independent set for which a function is defined. Now, to explain that also using an example, we have let me use the example that we had there, which is y is equal to x plus 3. This function, we have said that this is the independent. And then we have said this is the dependent. Then we are saying domain refers to all elements in the independent set for which the function is defined. So it means all element of x for which y is defined. An example of this is, let's say, pick a value of x is equal to 1. If you substitute 1 here, you are going to find y is equal to 1 plus 3, which is 4. 4 is a real value. So it means x is equal to 1 is a domain of this function. Now, in case, for example, we choose y is equal to root of x. Now, in this case, if you choose a value of x is equal to 1, similarly, you are going to find a value of y is equal to 1. Now, in this case, because the value of y is real, which is 1, then this 1 is also a domain of this second function. But in case you choose a value of x is equal to -1, the value of y is going to be root of -1, which is a complex value, not real. Not real. So because this is not real, then it means that this -1 is not a domain of this function. It has to be elements in the independent set for which this function is known or is defined. That is what a domain is. Now, a range, however, is all images of the element in the domain. So it means, for example, let me use this example that we had here. We have an example that y is equal to x plus 3. Now, using this example, we are putting x to be 1. I've said this is a domain. Why? Because when I put x to be 1, I'm going to get y as 1 plus 3, which is 4. Now, I'm saying the value of y for this domain is what we are calling the range. So this value is what we are calling the range. If you can see, all images of elements in the domain, this is the domain. Its image is the value of y, which is the range. So range are all values of the domain, its images on this other side in the dependent set. Now we have one more that we are supposed to define, the one that we are calling a codomain. Now a codomain is all element in the independent set. Let me use this example. Y is equal to x plus 3. You can decide to put x to be 1. You can decide to put x to be 2. Now when you put x to be 1, you will be finding y to be, put x here, 1 plus 3 is 4. Put x here as 2, 2 plus 3 is 5. Now these values are what we are calling range, but because they are still the values of the dependent set, I've said all element in the dependent set, because they are still values of the dependent set, then it means these one are values of the range, the way they are. Now when we are talking of codomain, we are meaning that all values of this x that is going to be giving us a value that we really need, whether it is a real number or not a real number, then that is a codomain. For example, let me use a definite that is going to show the distinction well. When we work with y is equal to root of x, we are having a value of x is equal to 1, and our value of y when we substitute is y root of 1, which is 1. Then when we choose a value of x equal to -1, our y is root of -1. And I'm saying these values of x, wherever they are going to give us a real value of y, this is a complex answer, whether they are going to give us a real value of y or they are not going to give us, we call them codomain. But the ones that are giving us the real value of y, like this one specifically, is a domain. It is giving us a known value of y, which is 1. That is what makes it a domain. But this one is not giving us a real value of y because we are getting a complex value. So that makes it not a domain, but a codomain. That is now what we are calling a codomain. And I've said a range are the values of x. It has to be defined. Range must be defined, and range goes hand in hand with the domain. So it means a value must have a domain for it to have a range. A value cannot have a range when the domain is not existing. For example, in this case where we are having y is equal to root of x, we cannot say that when we are having x is equal to 1, of course we are going to have y being also 1, but when we are having x equal to -1, our y will be a complex value, which is not real, not a real value. So we cannot say that because this one is not a domain, then we are calling this complex value that we are going to have in a range. This cannot be a range. It must be a real value. So when there is a domain, there is always a range. But when there is no domain, there is no range. But there can exist a codomain. That is the difference between domain, range, and codomain. As I've said, I'm repeating the definition. Domain refers to all elements in the independent set for which the function is defined, while range refers to all images of the element, all images of the domain which you have placed as the value of x. While codomain is any value of x, whether it is going to be giving you a real value of y, and I've said y is our dependent variable, whether it is going to give you a real value of y or not, that is a codomain. It doesn't matter whether it is going to give you a real value or it's not going to give you a real value. Let me pick an example. You have been told, state the domain for f of x is equivalent to 4 out of x squared minus 5x plus 6. You have been told to state the domain for this case. Now, for you to state the domain, you have to identify the points whereby domain, I've said and I've repeated several times that domain are the values of x that gives real value of y. So you have to identify at which point are we not going to have a real value of y. When the denominator is 0, domain don't exist when denominator is 0. When the denominator is 0. So it means we have to isolate the values whereby the denominator is going to give us 0, because 4 out of 0 is infinity, and this is not a real value. So we cannot state this as a domain. I said domain must give you a known value of f of x, which is the dependent set. So it means when x is 0, those values are going to be excluded in our domain. So we are going to say, let's find those values. We want to equate the denominator, because we are equating this to 4 out of x squared minus 5x plus 6. So we are equating these denominators. So minus 5x plus 6 is equal to 0. Now there are various ways of solving this quadratic equation. You can use factorization, you can use quadratic formula, you can use completing the square. Of course, that we can do in the next given video that we are going to form. But now this one, what we are going to use is the factorization method, and then the sum for this case is going to be -5. The product is going to be 6 times 1, which is 6. The numbers that can give you 6 are 2 by 3, and also another number that can give you 6 is 6 by 1. Now, if I put here -6, then it means the sum is going to be -5, but the product is not going to be +6. So we rule this out. If I put here negative 2 and this one -3, the sum is going to be -5 and the product is going to be 6. So our factors that we are going to use are those. So we are going to have x squared minus 2x minus 3x plus 6 is equal to 0. Factor out x into x minus 2. Then factor out 3, positive 3. 3 into x minus 2 is equal to 0. So we are going to have x plus 3, x minus 2 is equal to 0. Now, the last part of this is that we are now going to identify. So you say x plus 3, this can be equal to 0 or this being equal to 0, and then your answer will be 0. So x plus 3 equal to 0 gives you x equal to negative 3. X minus 2 equal to 0. This gives you x equal to 2. So it means when x is 3 and when x is 2, this value is going to be equal to 4 out of 0. So it means it will be unknown. Our f of x is not going to be real. So it means our domain will be inclusive of all values in the normal, will be inclusive of all values in the normal line from infinity of x and to positive negative infinity of x to positive infinity of x, negative to positive infinity of x, except these two values. X is equal to negative 3 and x is equal to 2. That will be our domain. In case you had been given another example, for example, say you have been given, for example, let me work with another different example. You have been given, for example, f of x being equal to root of x minus 1. Now, this case, this value is only known when the root is positive. So any value in the root that is going to be giving you a negative value must not be right. So we are going to pick a value. The value of x minus 1 must be either 0 or greater, because root of 0 is 0. But root of a negative value is not known. So we are going to equate this. So this means x is going to be greater or equal to, now we are going to be adding 1 on both sides. Let me work it in a better way. X minus 1 greater or equal to 0. So add 1 this side, add 1 also this side. This and this will become 0. So x must be greater than 1. So this becomes our domain. The domain for this case are all values of x that are equal or greater than 1. Any value below that is going to give you a negative value in the root. For example, pick 1. Pick 2, I mean. So when you pick, negative 2, pick negative 2, which is less than 1, then it means your f of x, pick negative 2 as x, your f of x will be root of negative 2, negative 1, which is the root of negative 3. And we have said root of negative 3 is complex value, not real. So it means this value is not known. So this domain doesn't exist. So the domain for this example will be all values of x greater or equal to 1. That becomes our answer. Now, what about the range? Range becomes the values that are corresponding to this domain. When you insert 1 here, your f of x will be root of 1 minus 1, which is 0. So it means our range will be all values of f of x that will be ranging or will be greater or equal to 0. It is the least value of f of x that you can get is 0. And when you put any other value, it will be an increasing way. You can see our x is greater than 1. So it means we'll be moving on in the positive direction. So our value of range will be increasing. So the least value that you can get is this. So this becomes your range. I hope this finds you well. Thank you for your time. And I hope this explanation about the domain and the codomain and the function and the range will help you understand what is a function, a domain, and a range. Now, if you have any question on a function, domain, range, or any kind of question that has been bringing problems into your mind, you can write them in the comment section, and the next time we'll be having a video, we'll specifically do that question so that we can consider our viewers, and we always wish them to ensure that they pass well, and that's our target, to ensure that calculus become a very easy topic. Now, please like, subscribe, and turn on notification, because if you don't turn on notification, you will not understand or you will not know when I have posted a new video. Thank you for your time and welcome next time.